Hello everyone, I'm Kailash Chitri, bearing number 20NS0205, and my topic for the assignment is KATER'S pendulum. In preparation of my assignment, I had to take the help and guidance of respected Dr. C.P. Khatibara, who deserve my deepest gratitude. As the completion of this assignment gives me much more pleasure, I would like to show my gratitude for giving us such a golden opportunity to this wonderful project on the topic, which also helped me in doing a lot of research and I came to know about so many new things. I am really thankful to them. Secondly, I would like to thank my parents and friends who helped me a lot in finalizing this project within the limited time frame. Introduction. A KATER'S pendulum is a reversible free-swinging pendulum invented by British physicist and army captain Henry Kater in 1870 for use as a gravimeter instrument to measure the local acceleration of the gravity. Its advantage is that unlike previous pendulum gravimeter, the pendulum centers of gravity and center of oscillation do not have to be determined, allowing a greater accuracy. For about a century until the 1930s, the KATER'S pendulum and its various refinements remain the standard method for measuring the strength of the Earth's gravity during geodetic survey. It is now used only for demonstrating pendulum principle. Aim. Harris pendulum explained and its aim to determine the value of acceleration due to gravity using Carter's pendulum. Apparatus required a Carter's pendulum, a stopwatch, and a meter rod. Theory. The time period of the physical pendulum is given by 2 pi I by mgl, that is be equation 1, where I is equals to moment of inertia with respect to the axis of oscillation, m is equals to total mass of pendulum, g is equals to acceleration due to gravity, and l is equals to distance between the center of mass of the pendulum and the axis of oscillation. The radius of gyration is given as k is equals to I by m, let it be equation 2. Equation 1 for the period of physical pendulum can be written as t is equals to 2 pi k square yt gt. Let it be equation 3. For the parallel axis theorem, we have k square is equals to k square centimeter plus l square. Let it be equation 4, where k small k centimeter is radius of gyration about the center of mass, and as before c is the direction distance from the center of mass to the pivotal to one of the unit is. Then equation 3 becomes t is equals to 2 pi root over whole root over k square c centimeter plus c square by gl. Let T1 and T2 be the period with the pendulum is swinging from pivot 1 to pivot 2 respectively. L1 and capital L1 and L2 are the distance from pivot 1 to and pivot 2 to the center of mass. Then T1 is equal to 2 pi root over k square centimeter plus l square by gl square. Let it be equation 6. Solving the k square centimeter, the fixed ratio of the gyration about the center of mass, we can find that k square centimeter is equals to g gl1 minus r1 minus r1 square minus l1 square by 4k square is equals to gl2 t square minus t minus t2 square by 4 pi square. After some multiplication it gives us 8 pi square by g is equals to 8 t1 square plus t2 square by l1 plus l2 plus t1 square minus t2 square by l1 minus l2, that is equation 9. Procedure. Balance the pendulum on sharp edge such that the smaller weight are at symmetrical distance from CG. Now move the position of its center of gravity and make sure that distance of the unit edge K1 and K2 from CG. This will give the value of L1 and L2. Suspend the pendulum with knife edge K1 and set it to the oscillation with small amplitude. Note the time for 10, 20 and 30 oscillation respectively. Now suspend the pendulum with knife edge K2 and set it to oscillate with small amplitude. Note that Note the time for 20 and 30 oscillation. Suspend one pendulum with small edge K1 and set it to oscillation with small amplitude. Note the time for 50 oscillation. Take mean value of it. Similarly suspend and the pendulum with knife edge K2 and note the time for 50 oscillation. Take mean value of it. Observation. Least count of stopwatch is 0.01 second and the percentage error goes 9.80665 minus 9.81094 millisecond into 100 by 9.80665 millisecond square is equals to 0.00429 into 10 to into 100 by 9.80665, that's equals to 0.047. The precaution: the two knife edges should be parallel to each other. The amplitude of vibration should be small so that the motion of pendulum satisfy the condition of small harmonic motion. To avoid any irregularities of the motion, and the time period should be not after the pendulum have oscillation to avoid friction. This should be a glass surface or rigid support. Conclusion: from the above experiment, the value of acceleration due to gravity was found to be 9.81094 meters second square, and its corresponding calculation percentage error was to be 0.047 percentage. Thank you.